Students, now we will discuss parallelogram law of vector addition. Parallelogram law of vector addition, it states that if two vectors are represented completely in magnitude and direction by the two adjacent sides of a parallelogram, then their resultant is represented completely in magnitude and direction by the diagonal passing through their point of intersection. For example, suppose this is a parallelogram OACB. OA is represented by a vector P. Vector Q is represented by adjacent sides OB. Then the resultant is represented. The angle between vector P and Q is theta. Then the resultant is represented completely in magnitude and direction by the diagonal OC passing through the point of intersection of vector P and vector Q, O. That is, vector R is the resultant vector of vector P and vector Q, making an angle phi with vector P. That is, vector R is equal to vector P plus vector Q. This is the statement of parallelogram law of vector addition. Suppose a parallelogram OACB, let a vector P denoted by a side OA of the parallelogram OACB, that is, P vector is represented completely in magnitude and direction by the side OA, and vector Q denoted by a side OB of the parallelogram OACB, that is, vector Q is represented by adjacent side OB of the parallelogram OACB at an angle theta. That is, angle between vector P and vector Q is theta. Then by parallelogram law of vector addition, the resultant vector R is given by diagonal OC of parallelogram OACB. That is, OC represents the resultant of vector P and vector Q, making an angle phi with the vector P. The angle between vector P and vector R is phi. Therefore, the magnitude of vector P is equal to mod of P vector, or it is equal to simply P, capital P, is equal to side OA of the parallelogram, and magnitude of vector Q is equal to mod of Q, or simply capital Q, is equal to OB, and magnitude of vector R vector is equal to mod of R vector, or simply capital R, is equal to OC. It means we are given OA, OB and theta. We have to find OC and phi. Phi for the direction of resultant vector. Draw CD perpendicular OA which meet OA produced at point D. This is OA is produced and CD drawn perpendicular on OA. This is right angle and point is D. The angle CAD is also equal to theta. They are the corresponding angle because OB parallel AC. In right angle triangle ODC, this is right angle triangle ODC. So in right angle triangle ODC, according to Pythagoras theorem, OC hypotenuse, so OC square, that is square of hypotenuse, is equal to OD square base square plus CD square height square. This is the Pythagoras theorem, or OC square is equal to, now OD is equal to OA plus AD. So put its value, it become OA plus AD whole square plus CD square. Now in the right hand side, open the bracket, we get OC square is equal to OA square plus AD square plus 2OA into AD plus CD square, or OC square is equal to OA square. Now combine AD square plus CD square, we get plus within the bracket AD square plus CD square plus 2OA into AD. Let it be equation number 1. Now in right angle triangle ACD, in right angle triangle ACD, according to Pythagoras theorem, base square AD square plus height square CD square is equal to hypotenuse AC square is equal to AC square. So put this value in equation number 1. So we get OC square is equal to OA square plus AC square plus 2OA into AD, or OC is equal to R, so it become R square is equal to OA is equal to P is equal to P square plus AC is equal to OB, opposite sides of parallelogram, is equal to Q. So it is equal to P square plus Q square plus 2P into AD. Let it be equation number 2. Again in triangle ACD, AD base upon AC, which is hypotenuse, it is equal to cos theta, or AD is equal to AC cos theta, or AD is equal to Q cos theta, because AC is equal to OB is equal to Q. Let it be equation number 3. Now put this value in equation number 2. So we get R square is equal to P square plus Q square plus 2P into Q into cos theta. Taking square root, we get capital R. The magnitude of resultant vector is equal to square root of P square plus Q square plus 2PQ cos theta. Let it be equation number 4. By this formula, we can find the magnitude of resultant of two vector P and vector Q. Again in right angle triangle, triangle triangle, right angle triangle, triangle ODC, tan phi is equal to height CD upon base OD, or tan phi is equal to CD upon OD is again equal to OA plus AD. Now put the value of OA and AD. Tan phi is equal to CD upon P plus Q cos theta. Let it be equation number 5. Again in right angle triangle, triangle ADC, we get CD upon AC. CD is height upon AC is hypotenuse. It is equal to sin theta, or CD is equal to AC sin theta. Now because AC is equal to Q, the magnitude of vector Q, therefore CD is equal to Q sin theta. So putting this value in equation number 5, we get tan phi is equal to Q sin theta upon P plus Q cos theta. So by this we can find the value of angle phi, and we can find the direction of resultant vector R. Put it equation number 6. So equation number 4 and equation number 6 gives the resultant vector of sum of two vector P and vector Q. Hence the magnitude of resultant is equal to square root of P square plus Q square plus 2PQ cos theta, and direction is given by angle phi, which is given by tan phi is equal to Q sin theta upon P plus Q cos theta. So by using these two formula, we can find the resultant of addition of two vectors, vector P and vector Q, inclined at an angle theta. So thank you very much.